let's start with alkyl and aryl halide. Alkyl halide is are when bonded with one halogen. This halogen may be fluorine, chlorine, bromine, or iodine. We can say Rx in place of X. We can put fluorine, bromine, or all four halogens. This is what we call alkyl halide. Let's start with the preparation of alkyl halide. Method of preparation of alkyl halide. Alkyl halide are prepared from alkene, alkane, alcohol, and from alkene. If you want to prepare alkyl halide, for example, we have taken CH3. This is the alkene. If you want to prepare alkene, alkyl halide from alkene, we add halogen acid like HCl, HBr, HI. As we know that alkene are rich in electron due to the presence of this pi bond. Alkene are electron rich due to presence of pi electron. So if it is electron rich, there are two things. One is electrophile, other is nucleophile. HCl form when dissolved in alkene, it is converted to H plus and Cl minus. H plus act as an electrophile and Cl minus act as a nucleophile. And we know that this alkene is electron rich. So it attract this electrophile, or this electron rich species attract nucleophile. Electrophile. अगर यहाँ पे electron rich है, तो electrophile पे ही सबसे पहले attack करेगा वो. So this alkene is approached by this H plus ion. So if H plus ion attack to this form, it forms a carbocation. It forms a carbocation. Both the electrons are shifted to this carbon. This carbon get negative charge and H plus attack to the negative and converted to CH3 plus. Now this carbocation is electron deficient. Now the nucleophile undergo reaction with this carbocation and form alkyl halide. This is secondary alkyl halide. This reaction takes place in the two steps. First is K1 and second is K2. Between K1 and K2, the rate determining step is the step where carbocation form. So K1 is the rate determining step. The molecule which form most stable carbocation will react with higher rate as compared to other. For example, if there are two different alkene, let's say this is one alkene, this is second alkene, this is third alkene, A, B, C, and all three alkene react with HCl. If this molecule react with HCl, carbocation will form at this position. If this alkene forms or react with HCl, carbocation may form in both the position because both are identical. This molecule when react with HCl, carbocation is formed in this position. This is secondary alkyl halide. This is tertiary alkyl halide. Sorry, this is tertiary carbocation. This is again secondary carbocation but having one ethyl group. So the most stable carbocation formed by tertiary. So highly reactive alkene with HCl is tertiary. So we can say alkene react with HCl to form alkyl halide. This is a two-step reaction mechanism. In the first step, carbocation form. In the second step, Cl attack to this carbocation. If we are talking about the drawback of this addition, this is the addition reaction. What are the drawback of addition reaction? Any reaction which form carbocation undergo rearrangement. Undergo rearrangement. This is the first drawback. Second drawback, if let's say this carbon is a chiral carbon, so this Cl minus may attack from above and below the plane. Therefore, complete racemization will occur if the carbocation form chiral. Clear? Now, let's say we have a molecule which consists of a 5-member ring, and in the alpha position there is a double bond. I have reacted this double bond with HCl So first H plus will attack and the carbocation form in the secondary position. So in the first step of this reaction, carbocation form and this is converted to CS3. This is a positive charge. Now in the second step, Cl minus attack to this carbocation. So before Cl minus attack to this carbocation, this 5-member ring undergo rearrangement. The rearrangement 5-member is converted to 6-member. First, this bond cleavage occur. This carbon get negative charge, positive, negative, positive. This positive, negative attack with this positive, and it is converted to 6-member ring, having one methyl group, and the positive. Now the Cl minus attack to this positive. So this is a rearrangement of carbocation. This is a major drawback of addition reaction of hydrochloric acid in alkene. Due to the formation of carbocation, almost all rearrangement of methyl shaped, phenyl shaped, hydride shaped, ring expansion, almost all thing occurs, and this is not a stereoselective reaction. Always the product form is racemic mixture. Is it clear? Clear? So this is the first method to prepare alkyl halide. Now, this addition of HCl follows Markovnikov rule. Clear? And in presence of H2O2, the reverse of Markovnikov, which is known as anti-Markovnikov. From these all 4 halogen acids, HF, HCl, HBr, and HI, which halogen acid shows anti-Markovnikov rule? Why HBr only? Why HBr shows anti-Markovnikov rule? Because in presence of H2O2, the mechanism follow is homolytic cleavage. It forms radical. In the 2-step of addition reaction, the HBr is the only halogen acid in which both the step are exothermic. Whereas almost all 3 halogen acids, one is exo, second is endo, first is exo. Only HBr shows both the reaction of exothermic. Is it clear? All these reactions you have already read in the hydrocarbon part. Let's say I have taken halogen acid HX. Clear? And this HX is treated with alkene in presence of H2O2. In presence of H2O2. Now we know that H2O2 and in presence of photon, it undergo homolytic cleavage. So this H2O2, HOOH, in presence of photon, first give HO free radical. This HO free radical react with HX to give H2O and X radical. Clear? Now, in this mechanism, when you add HCl in the absence of H2O2, the attacking species is the electrophile because alkene are electron rich. But when H2O2 is added, the attacking species is X radical rather than H plus. So, the 2-step reaction mechanism, in the first step, this alkene, when treated with this X radical, as we know that when the homolytic cleavage one radical form, the other molecules also undergo homolytic cleavage. So this is an X radical. Now this pi bond undergo homolytic cleavage. Is it clear? If it undergo homolytic cleavage, there it form 2 radicals, one at this position, another is this position. This X radical will combine with this carbon because this is secondary carbon radical which is stabilized by the hyperconjugation of both the methyl group. Is it clear? So can I say in the first step of this reaction, it form an intermediate which is carbon free radical, whereas in the addition of HCl, the intermediate form is carbocation, and in this reaction, the intermediate form is carbon free radical. Now, in the second step, this carbon free radical collide with HX. This carbon free radical collide with HX and convert it to CH2X. Is it clear? Now see, what are the bond cleavage in both the cases? Can I say in the first case, carbon and carbon bond cleavage occurs. So we have to supply the energy to break the homolytic cleavage of this pi bond. and there is a bond formation occur between carbon and X. So minus. Why minus? Because when the bond form, energy release. So can I say in the first reaction, if I have to calculate the value of delta H, I can say carbon pi bond cleavage occur, carbon halogen bond form, the energy is released. Whereas in the second case, if I have to calculate the value of delta H, the bond break between H and X. The bond break between H and X, and the bond form is C and H. Is it clear? Clear? Now, can I say if I take HCl, HBr, HI, or any halogen acids, the bond cleavage of this part and this part remain constant. Bond cleavage between this and this is not depend upon the type of halogen acid which you are taking, but the bond energy of these two may differ. The maximum bond energy will be of CF, then CCl, then CBr, and the least energy is CI. Let's say, for example, I am not taking about the bond energy. Let's say the energy required to break this carbon-carbon double bond is 50 joule. 50 joule. This is not the correct data. I am saying, let's say the energy required to break CC bond is 50 joule. And when the bond between carbon and fluorine form, the energy release is 100. Then the first reaction is exothermic. 50 joule is required to break the bond and 100 joule when it is released. So the overall energy release is 50. When carbon chlorine bond form, the energy release is 80. Again exothermic. Carbon bromine, the energy release is 60. Again exothermic. When carbon and iodine bond form, the energy release is approximately 30. So this is a endothermic. So the first reaction, can I say the first reaction for HF, HCl and HBr, this is exo, whereas for HI, this is endo. Clear? Now come to the second reaction. In this reaction, what we are doing, we are undergo homolytic cleavage between H and X. There is a homolytic cleavage between H and X. Higher the electronegativity of the halogen, higher will be the energy required to break the homolytic bond. So can I say C and H, the bond energy remain constant. Let's say the bond energy is 50, or let's say the bond energy is 70 joules. For example, when C and H bond forms, 70 joule of energy is released. Now, if H and F, there are 4 halogen, HF, HCl, HBr, HI. Highest energy required to break is HF, then HCl, then HBr due to electronegativity. Now, to break the HF bond, we require maximum energy, let's say 100 joule. So 100 joule is required to break the bond and 70 joule is released. That means overall 30 joule is absorbed. So for HF, this is endothermic. And for HCl, let's say 90 joule is required. So again, for HCl, it is endothermic. For HBr, the energy required to break the bond, let's say 60. So this is exo. And HI, let's say 50, again exo. So can I say, for the second reaction, HBr and HI are exo, whereas HF and HCl are endo. Now, which halogen acid? Both the steps are exothermic. HBr. Therefore, HBr shows anti-Markovnikov rule in presence of H2O2. Is it clear to all? Any doubt? Any doubt? So this is the first method of preparation of alkyl halide. Preparation of alkyl halide from alkene. Preparation of alkyl halide from alkene. From alkene, we can able to prepare dihalides also. Dihalide means if I take alkene, this is second method on which I am preparing alkene I am preparing alkyl halide from alkene. We take bromine in presence of CCl4. Bromine in presence of CCl4. Now, as we know that you have already read the electrophilic aromatic substitution, right? Benzene react with electrophile because it is electron rich. If I have to add one bromine in the benzene ring, the reagent required is Br2 in presence of AlCl3. This AlCl3 release one electrophile Br plus, that Br plus attack to the benzene ring. So benzene ring is electron rich, still we required one Lewis acid, that is AlCl3. Now in alkene, I have taken bromine in presence of CCl4 and the addition takes place. That means, can I say alkene is much more electron denser as compared to benzene? Alkene is much more electron denser as compared to benzene. And in alkene also, the reaction is always initiated by the electrophile. When I have added HCl, the electrophile is H plus. But in presence of Br2 and CCl4, how the electrophile is formed? We can say alkene consists of a pi cloud. This is a pi cloud. When I have added bromine in alkene, this pi cloud polarize this bromine. Bromine is non-polar molecule. This pi cloud polarize this bromine and the electron shifted towards this bromine. This is known as induced polarization. This induced polarization is take place due to the presence of this pi cloud in the alkene. Due to this induced polarization, this bromine gets partial negative and this bromine gets partial positive. Now this slowly this bond cleavage occur and this Br plus enters in the alkene. Is it clear? So first step of this reaction is perfectly at equilibrium, which form 3-member ring with Br2. This CH3, CH, CH2 and Br. Is it clear? With the formation of Br minus. And in the second step, this Br minus attack from the above side and the bond cleavage form, and it form dihalo compounds. And it form dihalo compounds. Clear? So can I say the bromine addition take place NT? So addition of bromine in presence of CCl4 is 100% NT addition. Is 100% NT addition. Now what is the effect of NT addition in the stereochemistry? Let's say we have taken a cis alkene. We have taken cis alkene and this molecule is treated with Br2. Now this Br2 undergo addition NT. Therefore, it can add two type of molecules. One is this and second is the mirror image of this. Is it clear? So cis alkene when undergo bromine addition in presence of CCl4, it give a racemic mixture. It give a racemic mixture. If you want to prepare the racemic mixture by the NT addition, you have to draw this alkene, the Sauer's projection, then add bromine in the NT position. Then come into the staggered conformation, convert into the Fischer projection. You will get the racemization mixture. Let's say you have taken a trans alkene with Br2. It give meso compounds. It give meso compound. Is it clear? So trans alkene give meso, whereas cis alkene give racemic mixture. Clear? Any doubt? Look at this reaction mechanism. It consists of two steps, K1 and K2. Between K1 and K2, which is the rate determining step? First. Can I say first is the rate determining step? And according to Lee-Chatelier principle, in the first step, there is an equilibrium between alkene and bromine. So if we want to proceed this reaction in the forward direction, we have to take the higher concentration of bromine. अगर हम higher concentration bromine का लेंगे तो Lee-Chatelier principle के according ये reaction आगे को move करेगी. So if the reaction goes forward direction, we have to take the higher concentration of Br2. Let's say we have not taken the higher concentration and we have taken lower concentration of bromine, Br2 at low concentration. The two effects observed in low concentration of bromine. One, as we know that bromine is a non-polar molecule. Bromine is a non-polar molecule. To undergo this addition reaction, we have to cleavage this bond. We require this cleavage of this bond as heterolytic cleavage. Why this heterolytic cleavage occurs? Because it is a non-polar molecule. As I have discussed, this alkene polarizes bromine. If the concentration of bromine is very low, the polarization may not occur. If the polarization may not occur, the heterolytic cleavage may not initiated. So we cannot be able to form the electrophile. Now, when you take the low concentration of bromine at high temperature, the bromine undergo homolytic cleavage forming Br free radical. If Br free radical form, it react with this hydrogen to form allylic substitution, and the product is substituted alkene. Clear? So if you take high concentration of bromine, it undergo addition to give dibromo compound. If you take low concentration of bromine, it give allylic substitution. Clear? So to initiate this allylic substitution, we required low concentration of bromine. But in some cases, it is very difficult to observe the exact low concentration of bromine. So to do the allylic substitution, generally we add or we use N-bromosuccinamide. N-bromosuccinamide. This is succinic acid. Succinic acid, when heated, succinic anhydride treated with ammonia to give NBS, N-bromosuccinamide. This NBS always give allylic substitution. This NBS always give. Why? Because this NBS, nitrogen is more electronegative than this bromine. This NBS is treated with HBr. This NBS is treated with HBr, and the HBr is a provider of Br minus. This Br minus attack to this bromine, and this electron are accepted by this hydrogen. Sorry, this nitrogen. Nitrogen get negative charge, negative and positive form a bond, and it gives succinamide. It gives succinamide along with the formation of Br2. Look at this reaction. These are also in the equilibrium. So in the equilibrium, the bromine concentration is very low. When you add alkene, it establishes a simultaneous equilibrium between these two reactions. Now this bromine undergo reaction with the alkene to form substituted product rather than addition. ऊपर से गया? Clear? देखो, हमें ब्रोमीन की कंसंट्रेशन कम चाहिए. कम के लिए तो आप ये कर सकते हो कि भाई ब्रोमीन कम डालो. कम को डिफाइन करना बहुत मुश्किल है. For example, if you had taken very small amount of bromine, it may be higher concentration for the alkene. So what we do, we react NBS in presence of HBr. So how it provide low concentration of bromine? It react with HBr to form bromine, and this is in the equilibrium. Correct? Now, in this equilibrium, the concentration of bromine must be very low. Now you add alkene. As soon as you add alkene, it collide with this bromine at a low concentration. This bromine will be adsorbed or reacted. As this bromine is adsorbed, this reaction goes forward and it maintain a low concentration of bromine, and entire reaction undergo substitution. Clear? Clear? So, if you want to do allylic substitution, you have two options. One, you take low concentration of bromine. Second, you take NBS in presence of HBr. Allylic substitution can also be achieved by one more reagent or one more change in the reaction, that is temperature factor. How temperature affect this reaction? As we know that every reaction is controlled by the free energy, which can be written as del H minus T delta S. Delta G equal to del H minus T delta S. Now, when alkene react with bromine and it undergo addition to give this 1,2-dibromo compound, can I say there are two molecules and the product form is 1. There are two molecules in the addition and the product form is 1. So this direction, the entropy decreases because the randomness decreases. But in the substitution case, two molecules are converted to two molecules. The entropy remain constant. If the entropy is constant and you increase the temperature, the delta G must be more negative. So it will be more spontaneous towards substitution. Therefore, higher temperature prefer substitution rather than addition. Clear? Is it clear to all centers? So this is the second method of preparation of alkyl halide from alkene. So we have prepared alkyl halide by two different methods. One is addition, in which carbocation formation is the rate determining step. The major drawback is formation of racemic mixture or diastereomers if already there is a one chiral carbon. The second method is addition of bromine. Addition of bromine is 100% anti. Addition of bromine is controlled by the concentration of bromine. Higher the concentration, higher will be the formation of addition. At lower concentration, substitution. Lower concentration can be achieved by NBS or low concentration of Br2. Allylic substitution can also be take place at higher temperature because delta G is more negative. Okay. If I say same in the same reaction, this is alkene and this is Br2, and we are talking about the addition reaction. So in the addition reaction, this alkene, this pike cloud attack to the bromine and start polarizing. Due to this polarization, it form Br plus and the addition take place. Now, if I reduce the pike cloud density, and it is decreases, will it be possible that polarization occurs? I have taken high concentration of bromine in presence of CCl4. Look this example, CCl3 double bond C, CCl3. I have added 4 group which exhibit a strong minus I effect. If all 4 group exhibit strong minus I effect, the pike cloud density decreases. Now, if the pike cloud density decreases, so this low concentration or low density of bromine are not sufficient to polarize this bromine. So, if in this molecule I have taken high concentration of bromine in presence of CCl4, the answer is no reaction take place. Is it clear? So, the pi electron density is very important to initiate the reaction. But if in the same reaction I have added a small amount of Lewis acid like AlCl3, the reaction start. Why? Because AlCl3 react with this bromine to form Br plus, and that Br plus attack to this alkene. Is it clear? Now in the same reaction, if I take solvent in place of CCl4, I have taken water. Tell me, addition of bromine will be, rate of addition of bromine will be higher in CCl4 or higher in water? Addition of bromine is, rate of addition of bromine is higher in water or higher in CCl4? Water. Why? Because we know that the in addition reaction, we required polarization of this bromine. And we know that the polarization of bromine will be take place higher in the polar solvent. But still we used to take CCl4 because in presence of water, what happened? This CH3, it form a 3-member ring. In the second step, there is one Br minus and huge amount of H2O. This 3-member ring is unstable. One Br minus and large quantity of water. and large quantity of water having lone pair. So water is also a good nucleophile. So in place of Br minus, H2O will attack and it form halohydrin rather than dibromo compound. It form halohydrin rather than dibromo compound. Is it clear? So generally this reaction is take place in presence of CCl4. Clear? I've added this molecule, 2 molecule of NBS. What will be the product? NBS, N-bromosuccinamide, allylic position. AB, which is correct. A होगा, फिर तो B है. Between A and B, which will be the major product? B. Why B? First, one NBS attack to the allylic position and it formed this molecule. Now there are two options. One, another Br free radical can react with this and form a radical this position or in this position. This radical is stabilized by the resonance, whereas this radical is again stabilized by this benzene resonance as well as the resonance due to the lone pair. So this radical is more stable. Therefore, the second step, the radical form in this position, and bromine will attack at the same carbon. Is it clear? So if you have more than one allylic group, so you have to find out the most stable radical. Higher the stability, higher will be the chance to react with this molecule. For example, if this is an alkene, let's say, and I have added one NBS. So at this position, bromine will attack, or at this position, bromine will attack. In this position, the radical is stabilized by the resonance. In this position, the radical is stabilized by the resonance, but this radical is again stabilized by the hyperconjugation of two methyl group, not inducting effect. Radical में inducting effect नहीं होते, सिर्फ hyperconjugation होता है. So this radical is stabilized by the hyperconjugation of these two methyl groups. So Br will attack at this position. Clear? Simple. So these are the two methods of preparation of alkyl halide from alkene. Now, the second method is preparation of alkyl halide from alcohol, ROH to RCl. ROH to RCl. This can be achieved by the three different reagents. One is Lucas reagent, zinc chloride in presence of HCl. Second is PCl5, PCl3. Third is SOCl2. So PCl5, PCl3, SOCl2 are the most popular method and very good method to prepare alkyl halide, because all the three reagents form alkyl halide without forming carbocation. So no rearrangement, stereoselective reactions. So let's start with the PCl5. When I take PCl5 or PCl3, this alcohol is converted to alkyl halide without forming, and one molecule of PCl3 can able to convert three equivalent of alcohol to alkyl halide. So it is very useful reagent. So let's start with the mechanism of action. This phosphorus consists of 3 chlorine. Phosphorus consists of 3 chlorine and 1 lone pair. Correct? This is the structure of PCl3. लिखने से पहले सुन लो पहले. This is the structure of PCl3. Phosphorus consists of 1 lone pair and 3 chlorine. Generally, this reaction is taking place in small acidic medium. So first H plus will attack to the lone pair. When H plus attack to the lone pair, the charge of phosphorus will be positive. In the phosphorus, there is a vacant d orbital, so the octet is not in the 8. It can increase from 8. So this phosphorus can able to accept the pair of electron from alcohol. So second step, alcohol, oxygen consists of lone pair. This lone pair attack to this positive charge, and it form pH, Cl, 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 OR, H plus I have removed so that the positive charge is neutralized. Clear? So in this reaction, in this step, this chlorine having lone pair approaches this carbon because this is partially positive and attached with the oxygen, correct? If this chlorine approaches this carbon get partial positive charge, and these electrons are moving toward this chlorine to compensate this partial positive. So this phosphorus generate partial positive charge, this lone pair move to this direction because these electrons are coming to the oxygen. So in a one step reaction without forming any charge in the carbon, it is converted to this molecule. Double bond plus RCl. Backside attack, 100% backside attack. If this is capital R, the product will be capital S. If this is capital S, the product will be capital R. Complete inversion. Complete inversion. So this RCl form, तो ये पहला RCl बना है, but it consists of two more halogens. So in the again the medium is slightly acidic. So this H plus attack to the double bonded oxygen, and the oxygen get partial positive charge. Both the pi cloud is accepted by the OH group, and phosphorus again generated partial positive, complete positive charge. One equivalent of alcohol will attack to this partial positive charge, and it is converted to Cl, Cl, O, R, and one OH. Correct? The same mechanism which I have explained in this step is repeated. This lone pair attack to this carbon. One more RCl form, having one double bond of O, Cl plus RCl. This is the second molecule of RCl form. Again, the molecule consists of one more alkyl halide and the medium is acidic. So the H plus attack to this lone oxygen. H plus attack to this oxygen, and the same mechanism, double bond OH, Cl, this is positive. Again, this oxygen accepts the electron, generating positive charge in the phosphorus. And one more molecule of alcohol will attack to this phosphorus positive, correct? It will get P, H, OH, OR, OH. Same mechanism again attack. Finally, this is converted to phosphoric acid, forming one alkyl halide. See, first alkyl halide, second alkyl halide, third alkyl halide, forming phosphoric acid. Without any rearrangement, without any forming carbocation. Clear? Should I rub the board? वो वीडियो से भी तो देख के लिख सकते हो. this is the third method of preparation of alkyl halide. What is the advantage of this method? इस मेथड का एडवांटेज क्या है? नो रीअरेंजमेंट. अगर तुम अल्कोहल में HCl डाल के भी बनाओगे तो कार्बोकेटायन बनेगा ना. कार्बोकेटायन बनेगा तो सारे रीअरेंजमेंट नहीं हो जाएंगे. So the advantage of this reaction is the rearrangement will not occur. Is it clear? Clear? Now, what is the stereochemistry of this carbon or this reaction? Let's say this is a methyl hydrogen. This is OH, ethyl group. So this is a chiral carbon. So it can rotate plane polarized light either right or left. It may be dextro or livio. So in this reaction, if I say according to priority wise, this is 1, 2, 3, 4. Least priority must be in this plane. Now 1, 2, 3. That means it goes clockwise or anti-clockwise. So this is capital S. This is capital S. Clear? Now, when you react this alcohol with PCl3 or PCl5, it gives complete backside attack from the mechanism I have already explained. Backside attack means this S is converted to R. This S is converted to R. That means the product form will be like this. This is capital R. Clear? Inversion does not mean that the optical rotation are inverted. Inversion means is R is converted to S. ऐसा हो सकता है कि ये clockwise, this clockwise according to priority, not according to plane polarized light. Let's say this rotate plane polarized light in the right direction. So this is dextro. We cannot say this is livio because these two molecules are not the isomer of each other. These two molecules are not the isomer of each other. These are two different molecules. But if in place of Cl there is a OH, then this is R, this is S. If this is a OH, then they are the mirror image of each other. If they are mirror image of each other and one is S, other is R, they must be an enantiomer. Then the optical rotation must be equal in opposite direction. But in this case, I have removed this Cl with or replaced with this Cl with OH group. So if this is a S, this is R, I will say this reaction is 100% inversion. 100% inversion. And it give optically active compound. Optically active compound. Clear? Clear? Now, let's say we have treated this molecule like this. This is a OH group. And it consists of pH, H. Clear? So this is again a chiral compound like this. See, this molecule, it consists of two chiral carbon. Two, let's say this is R and this is S. When I treat this molecule with a PCl3, this R will remain constant. So it forms R and this S is converted to R. So this is RS, this is R. Clear? So in this case, the inversion of one carbon occur, but the second carbon remain constant. So generally they form diastereomers also. Clear? So what is the advantage of PCl3 or PCl5? They convert alcohol to alkyl halide without forming any carbocation and no rearrangement occur. We can able to justify the stereochemistry of the product. Clear? So this molecule, there is a backside attack occur. So if I say ROH, the Cl will attack from the backside and R is converted to S. R isomer is converted to S isomer. Now the second reagent which we are going to use is SOCl2. SOCl2. It shows two different type of mechanism. Let's say this is ROH and it is treated with SOCl2. SOCl2, like PCl3 and PCl5, is a very good reagent to convert alcohol to alkyl halide without forming any carbocation. But one more advantage is that SOCl2 shows two different type of mechanism. One in the presence of pyridine and one in the absence of pyridine. What is the difference between presence and absence of pyridine? When alcohol is treated with SOCl2, the first step is the lone pair attack to the sulfur and both the oxygen accepted by this oxygen. So the first reaction is SO negative, Cl, this is positive. Clear? Now the plus R effect of this oxygen, remove this Cl along with this H plus. So HCl will be removed and it form ROS double bond OCl. Clear? So I have told you that SOCl2 undergo two different type of mechanism. One in presence of pyridine and one is absence of pyridine. What is the difference between these? In the both the mechanism, this will form ROS double bond OCl. So if I take pyridine, the reaction will be like this. Pyridine is a base. Pyridine is taken in presence of HCl and form a pyridinium chloride. Now, pyridine chloride is a source of Cl minus. This Cl minus attack this carbon from backside, and this oxygen is converted to this and chlorine removed. SOCl2 gas and HCl removed, and it form RCl plus SO2 plus HCl. Clear? But this reaction is take place in presence of, let's say I have not taken pyridine. So in the absence of pyridine, ROS double bond O Cl. Cl consists of lone pair. This chlorine approaches this carbon from front side attack and it gives RCl plus SO2. So we can say the two reactions are, one in the presence of pyridine, it gives an inverted product, whereas in the absence of pyridine, it gives retention of the product. Clear? देख लो नहीं है. Look, let's say this is RCl, ROH, and this carbon is a chiral carbon. अगर ये chiral है तो कैपिटल R या कैपिटल S दो में से एक होगा. मैं इसका स्ट्रक्चर भी बनाता हूं. ये कार्बन, ये मिथाइल, दिस इज OH, H, और ये ले लेते हैं हम फिनाइल ग्रुप. ठीक है. नाउ सी दिस कार्बन अकॉर्डिंग टू प्रायोरिटी रूल 1, 2, 3. दिस इज S टाइप. अगर इस Cl की जगह इस OH की जगह Cl आए S होगा, और अगर Cl बैक साइड से अटैक करा के OH को फ्रंट से लीव कराए R होगा. तो क्या ये कहना ठीक होगा कि दिस मॉलिक्यूल, इफ दिस इज a S, if the reaction take place from backside attack, it is converted to capital R. This is what we call inversion. Now, if this is S and the attack occur from the front side, so S is converted to S. This is called retention. Clear है? PCl3, PCl5 में क्या हुआ था, inversion या retention? Inversion हुआ था क्योंकि बैक साइड से अटैक हुआ था. ठीक है, अब समझो, when ROH is treated with SOCl2, it forms this complex. When this molecule is, this reaction is take place in presence of pyridine, the source of Cl minus attack from backside, attack from, so S is converted to R in presence of pyridine. Let's say I have not taken this pyridine. So this molecule, there is no pyridine or there is no source of Cl minus which attack from backside. Now what I say, in this molecule, this is a single molecule having structure like this, isn't it? Now this chlorine, if provide electron to this carbon from front side, see this OH, this chlorine from front side. So this is the front side attack. So it will, S is converted to S. So retention. So in absence of pyridine, retention occurs. In presence of pyridine, inversion occurs. Clear? Clear to all? So can we say that in presence of SOCl2, both type of mechanism are observed, retention as well as inversion. So in the method of preparation of alkyl halide, we have completed almost 3 to 4 reactions. First reaction is preparation of alkyl halide from alkene when we have added HCl or HBr. So Markovnikov and anti-Markovnikov. Second is the addition of alkene in Br2 in presence of CCl4 or in presence of water or in presence of alcohol or in presence of phenol or in presence of any polar solvent. It also gives Markovnikov addition, but the addition is 100% anti. Clear? Third is preparation of alkyl halide from alcohol. We have used 3 reagents: PCl5, PCl3, SOCl2. PCl5, PCl3 give inverted product. If chiral compound is there, then only we can able to use the term inverted product. So PCl5 and PCl3 give R to S. SOCl2 give inversion as well as retention. In case of inversion, if you require inverted product from SOCl2, you use pyridinium chloride or pyridine in presence of HCl. If you want to prepare retention from R to R, you use only SOCl2. Clear? Good out? So this is all about the alkyl halide, aliphatic alkyl halide. Now we are talking about aromatic alkyl halide. In the aromatic alkyl halide, this is a benzene ring. This is chlorine. Clear? So this is benzene in presence of, or benzene make chlorine laga. So this is what we call aryl halide. Aryl halide can be prepared from different process. First is the simple preparation in which we generally take benzene in presence of halogen and Lewis acid, and halogen will attack to the benzene ring. Clear? So in this reaction, first halogen consists of lone pair. We know that the Lewis acid AlCl3 want to accept the pair of electron. This AlCl3 attack to this chlorine. So XX AlCl3. This is negative, positive. It gives X plus and AlCl3 X minus. Clear? Now, this is an electrophile. Benzene, 99% reaction, benzene react with the electrophile because it is electron rich. So this X radical react with benzene in the 2 different step. First step, benzene attack, electrophile attack to the benzene ring at any position, all are identical. In the second step, H plus is removed and it regain the aromaticity. So this is K1, this is K2. Which step is the rate determining step? K1 or K2? Which step is the rate determining? K1. Why K1 is rate determining? Because the aromaticity breaks. So if I say in this direction, the energy with respect to time, this is benzene ring, this is the first activated complex, this is intermediate, this is second activated complex, this is the final product. Why this graph is like that? When benzene is react with electrophile. सुन लो बाद में लिखना. This benzene is electron rich and an aromatic compound. When electrophile attack to this benzene ring, aromaticity break होगी. System की energy बढ़ गई. This is the first transition state. यहाँ पे क्या है ये? First TS. This is what we call TS1. इसका स्ट्रक्चर ऐसा होगा. ये बेंजीन रिंग है, ये इलेक्ट्रोफाइल है, ये पॉजिटिव चार्ज है. नाउ दिस पॉजिटिव चार्ज अंडरगो रेजोनेंस, एरोनियम आयन. ये डबल बॉन्ड यहाँ आएगा, प्लस यहाँ है, ऐसे मूव करेगा कि नहीं करेगा? तो जब पॉजिटिव चार्ज रेजोनेंस में जाएगा तो उसकी एनर्जी कम होगी. सो द एनर्जी कम हो गई. दिस इज द एरोनियम आयन, करेक्ट? इलेक्ट्रोफाइल पॉजिटिव. कोई डाउट? In the second step, the alpha position, this hydrogen, there is a bond cleavage between carbon and hydrogen. So we have to add the energy to bond cleavage. When we add the energy goes in the upward direction. Now there is a bond formation between carbon and carbon. So the energy goes to the downward. And this is an aromatic compound. This is stable. This may be more stable than this one or less stable than this one. It depends upon the type of halogen which we are using. So it formed two steps, and the first step is the rate determining step. Is it clear to all? Clear? As we know that bond between CH, CD and CT, the easiest cleavage is CH. Easiest heterolytic cleavage is CH. CH का bond सबसे जल्दी टूटेगा, CT का सबसे देर से टूटेगा. So if I say we have three molecules, one is C6H6, C6D6, C6T6, and it is treated with electrophile. The rate of reaction of ABC is higher with C6H6. Same for all. Because the rate determining step is K1 and the bond cleavage is in K2. Bond cleavage is in K2. Can I say in this reaction, isotopic effects are not observed? That means if for this reaction, the value of KH upon KD equals to 1. The value of KH upon KD equals to 1. Why I am saying isotopic effect? Because in some reaction, when the electrophile is very weak, the isotopic effects are observed. And one of the reagent is iodine, I plus. I plus is very poor electrophile. साइज में बहुत बड़ा है, पॉजिटिव चार्ज की डेंसिटी बहुत कम है. पॉजिटिव चार्ज अगर बहुत कम है तो उसकी एफिनिटी टुवर्ड्स कार्बन बहुत कम है. तो उसकी एफिनिटी अगर कम है तो वो रेट डिटरमाइनिंग स्टेप को डिक्रीज करने लगता है और स्यूडो फर्स्ट ऑर्डर की तरफ मूव करता है. अब इस केस में ये समझ आया तुम्हें? अगर सेम मैकेनिज्म इफ आई टेक प्लेस with chlorine, bromine, for both the cases, the value of KH upon KD equals to 1. Fluorine is very reactive. But in case of iodine, if I take I plus, see the first equation, this is iodine, positive, and in the second step, this is K2, and there is I minus, because I plus is attacked, one I minus left. ठीक है? अब now there are two things. One, if this iodine attack to this iodine, these two electrons come to this position, aromaticity regain, and this reaction goes to the backward direction. And if this hydrogen bond cleavage occurs, this reaction goes forward direction, and again the aromaticity gain. So this reaction, again the rate determining no doubt is K1, but there is a competition between the bond cleavage of Ci and bond cleavage of CH. In such cases, if this bond strength is increased, it will affect the rate determining step. So in case of iodine, the value of Kh upon Kd is greater than 1. Yeah. Clear? Other center can post their questions. So if you want to prepare halo benzenes, we have one method, Cl2 in presence of AlCl3. If I say between fluorine, chlorine, bromine, iodine, which is most reactive? Fluorine. Least reactive? Iodine. Which halogenation isotopic effects are observed? Iodination. Isotopic effect matlab Kh upon Kd. If you say I have taken Cl plus, Kh by Kd equals to 1, no isotopic effect is observed. But in iodination, isotopic effect are observed. Clear? Our second method of preparation of alkyl halide is from benzene. From benzene. This is benzene. Benzene is an intermediate. This is not the final product. This is an intermediate. When this benzene is treated with any halogen acid HX, it is converted into clear. Benzene can be prepared by different methods. One method is preparation of benzene from alkyl halide. For example, you have taken Cl and reacted Cl with NaNH2 and heated this. NaNH2, NH2 minus is a strong base. Now you can able to say that we are preparing alkyl halide also using alkyl halide. So you can able to convert chlorobenzene to bromobenzene by this method. So if I take NH2 minus a strong base, it eliminates a hydrogen, present alpha to the chlorine. If one hydrogen is eliminated, it converted to negative charge. Now this negative charge plus R effect, the Cl removed from the alpha position and it form benzene. Clear? So this is a pi bond, but the hybridization of this carbon is still sp2. Still sp2. But you know that if carbon form triple bond and 2 pi bond, the hybridization changes to sp. But in benzene, the hybridization of the carbon is sp2. That means there is a hybridized lobe which consists of negative and which consists of positive, and sidewise overlapping of this hybridized lobe forms this triple bond. Therefore, this benzene is highly unstable and reactive. Clear? Benzene can also be prepared from different methods. Clear? ऊपर से जा रहा है? Easy है तो. Benzene can be prepared from different methods like C double bond O, OH, Br. OH minus and heat. This OH minus can eliminate this hydrogen. Oxygen minus चार्ज आएगा. तो देखो ये CO2 अगर गैस बाहर निकलती तो दिस कार्बन गेट नेगेटिव चार्ज. फिर ब्रोमीन बाहर से निकला, यहाँ पे प्लस आया. Again form benzene. So benzene can be formed from decarboxylation. From T carboxylation. Now, third method to prepare benzene is dihalogen compound. When reacted with magnesium, it forms benzene. Dihalogen compound treated with magnesium, it forms benzene. See, in the benzene, in the first step, hydrogen and chlorine are removed. So this is what we call elimination. This is what we call, because hydrogen and halogen are removed. Elimination. Then, if you add HX, it undergo addition. So benzene is not the final product, but benzene is prepared by elimination, then it reacted by addition. So benzene is an intermediate of elimination addition reaction mechanism. Clear? Clear? So let's say this is a benzene and the bond cleavages occur from this pi bond. From this pi bond. Always remember that this pi bond is present in a plane. This pi bond is present in a plane, and rest all three pi bond are above and below the plane. That means all the resonating effects or the plus R minus R effect are operated through these three bonds. So this is not affected by the resonance, but affected by inducting effect. So I am talking about the addition of this benzene ring. Let's say this benzene ring is attached with a group which have minus I effect and plus R effect. Generally, in electrophilic substitution reaction, you decide the ortho-para meta-directing through plus R, minus I, all these effects. But in the addition of benzene, only inducting effect are observed, or only inducting effect will decide the position of incoming electrophile. Let's say it consists of minus I plus R, and I have added HX. I have added HX. So if this pi bond cleavage occurs, it can form by two methods. One, plus minus, and the second possibility is minus plus. Clear? Now, the plus R effect is not observed, so we will see only minus I effect. So if this group have minus I effect, it withdraw electron from benzene ring. So these two electrons will move to this direction and form this. So this will not form. So I am not seeing the plus R effect. Why? Because this plus and minus charge present in the plane, whereas the plus R and minus R effect observed above and below the plane. So this will be the structure. Now if this group exhibit, let's say, plus I effect, and it form a benzene ring. So plus I effect means it donate electron. So negative, positive, this will be. So in this case, the chlorine attack at the meta position of this group. Chlorine attack at the meta position, whereas in this group, chlorine attack at the ortho position. So ortho and para or meta is decided by the plus I as well as minus I effect. I have never observed the plus R or minus R. Clear? Is it clear? Solve this question. Chlorobenzene is treated with NaNH2 and liquid ammonia. Chlorobenzene again treated with NaNH2 and water. Chlorobenzene is treated with NaNH2 and methanol. NaNH2 form benzene, and the second reagent undergo addition. First elimination, then addition of the second molecule. Clear? the first molecule, NaNH2. This NH2 minus eliminate this hydrogen, forms benzene. Liquid ammonia. Liquid ammonia, there is a bond between N and H. This is a polar bond. So this polar bond reacts with this benzene. Both the electrons are taken by nitrogen. Nitrogen get negative and H positive. H positive attack to the negative and positive part NH2 minus. So the product form is aniline. Product form is aniline. Let's say only NaNH2 is given. Liquid ammonia is not mentioned. So you can able to prepare this benzene, but the molecule which is undergo addition reaction is not available. So benzene will never be the final product. Like in this equation, I have not given any molecule which undergo addition. So in that case, you just add two benzene molecule to form biphenyl. This is benzene, one more by benzene and opposite charge. They combine each other to form biphenyl. Clear? So if there is no molecule which undergo addition, you can able to combine two benzene to form this molecule. If there is some molecule given for the addition, you just break the polar bonds. So in second case, the polar bond is between H and O. So if I break the H and O bond, we can able to prepare phenol. In third case, the polar bond again between H and OH. So OCS3. In the fourth case, there is an alkene reacted with benzene. We prefer to form 4-member or 6-member ring. This is negative charge. Break both the bond, plus, minus, minus, plus, and add all the opposite charge. You can able to get the 6-member ring. Clear? This is an intramolecular addition. It forms a benzene ring and the polar bond are attached with this molecule. So it undergoes intramolecular addition. This hydrogen at this position. Clear? So solve this last one. Chlorobenzene in presence of furane and a strong base NaNH2. Chlorobenzene and NaNH2 you can able to prepare benzene. यहाँ तक हो गया. Now benzene is added with furane. See, I have cleavage all the bonds. So can I say it consists of two positive and negative charge. Now combine these opposite charge. You can get this. And this oxygen is a bridgehead position, which is unstable. So when this molecule is treated with H plus, it attacks to this oxygen because it consists of lone pair of electrons. And due to strain, this is more reactive also. So this oxygen is approached by the H positive, and this bond cleavage occurs, forming a carbocation which is stabilized by resonance. Now, this carbocation can be shifted to the alpha position so as to regain the aromaticity. The alpha position hydrogen eliminated, and the pH of the solution remain constant as present initially. Beta naphthol. Simple. Benzene. Break this bond, plus minus. Break all 4 bonds of furane, opposite charge. Add this plus and minus. You can able to get this molecule. Now, this molecule is a stable one, but this oxygen is present in the bridgehead position. If you add H plus attack to this oxygen and this oxygen get positive charge. अल्कोहल में जब तुम H प्लस डालते हो तो H प्लस ऑक्सीजन पे अटैक करता है, प्लस आता है, तो वाटर को एलिमिनेट करते हो ना. यहाँ पे भी वही करो. H का अटैक इस O पे हुआ, O पे प्लस चार्ज आया, तो ये वाले बॉन्ड हमने ब्रेक किए, यहाँ पे प्लस आया. ये रेजोनेंस स्टेबल नहीं है. देखो ये प्लस, फिर मैंने इन डबल बॉन्ड को यहाँ ले आया, प्लस यहाँ आया, अल्फा से H निकालती है, एरोमेटिक हो गया ना कंपाउंड, बीटा नेप्थॉल बन गया. क्लियर? ठीक है. So this is the second method of preparing or changing the alkyl halide. And the last method of preparing alkyl halide is from diazonium compound. Diazonium. You can able to prepare diazonium from aniline. What are the reagents which have to add? Or HNO2. NaNO2 in presence of H plus is also same. Structure of benzene I have already discussed. Let's say this is benzene ring. It consists of 6 carbon and 6 hydrogen. So look at this carbon. This carbon is sp2 hybridized. This carbon is also sp2 hybridized. Now the structure of sp2 is triangular planar. The structure of this sp2 is also triangular planar. There is a bond which is present above and below the plane. Let's say this lobe, sp2 lobe, consists of 2 electron and this is negatively charged. And this lobe consists of no electron and this is positively charged. This is hybridized lobe. The sidewise overlapping of this hybridized lobe forms a additional third bond. So I can say in benzene, this carbon is sp2, this carbon is sp2, this pi cloud is above the plane, this pi bond is the bond formed between the hybridized. So this pi bond is present in plane, whereas this pi bond present above and below the plane. Clear? KV Agra, is it clear? So let's start with diazonium. This is NH aniline when treated with HNO2 in presence of H plus. See the structure of HNO2. When we have added H plus and heated, water is eliminated and there is an electrophile generated, NO positive. Clear? We know that benzene is highly reactive towards electrophilic substitution. So if we have added NH2 group, it consists of lone pair of electron in 2p orbital. So the resonance is between 2p 2p. So it is a strong activator. Strong activator. So the ring is much more electron denser as compared to benzene. Now there is an electrophile. So there we have two options. Whether the electrophile can attack to the benzene ring because it is electron rich. Second, this electrophile can attack to the lone pair. Clear? Because nitrogen bond energy is higher than nitrogen carbon bond energy, therefore this electrophile will attack to the NH2 group. So the first step of this reaction, anode positive attack to lone pair of nitrogen. This nitrogen get positive charge. Now the first step, intramolecular proton exchange. Intramolecular proton exchange clear? Again, if you heat this molecule, it is converted to benzene diazonium chloride. Benzene diazonium chloride. This is a very rare molecule which undergo nucleophilic substitution in the benzene ring at room temperature. In the benzene ring at room temperature, and the mechanism is known as SN1AR. Nucleophilic substitution first order forming aromatic compounds. Is it clear? So let us discuss how to prepare chlorobenzene from this diazonium. Chlorobenzene from diazonium through the path of SN1AR. Clear? Any doubt? This is benzene diazonium chloride. In the first step, K1, nitrogen gas is eliminated. In the second step, K2, the nucleophile, because we are preparing chlorobenzene, the nucleophile will be Cl minus. In the second step, we have added nucleophile and it attacked to this position. So between K1 and K2, which is rate determining? K1, K2, which is rate determining step? K1, because this positive charge is highly unstable. Now, if I take nucleophile as Cl minus, Br minus, I minus, CS3 minus, these four are the nucleophile, for which case the rate is maximum for these four. Between Cl minus, Br minus, I minus and CS3 plus, for which nucleophile the rate is maximum? Same. All are same, because this reaction, the rate determining is K1, and in K1 nucleophile is not involved. Nucleophile involved in the second. So this is not depend on the nucleophile. The only thing which control the reaction is nature of this benzene diazonium. Therefore, this reaction is known as nucleophilic substitution first order, SN1AR, first order with respect to diazonium. First order with respect to diazonium. Now still, if we are comparing the rate of reaction, we know that the rate is controlled by the K1. In K1, there is a bond cleavage between carbon and nitrogen. There is a bond cleavage between carbon and nitrogen. So, between carbon and nitrogen, which is more electronegative? Nitrogen. So, electron are towards nitrogen. And this bond cleavage occur like this. Both the electrons are taken by the nitrogen and C plus and N2 gas. If I put any group, if this group is the electron donor, it push electron towards nitrogen and the hydrolytic cleavage will be faster. If this group is electron withdrawing, it withdraw electron and the electron come towards carbon. The bond will be more stronger and rate will be decrease. So we have 4 different groups. Let's say A, there is a methyl group which exhibit plus I effect. B, there is a NO2 group which exhibit minus I and minus R effect. C, there is CCl3 which exhibit only minus I effect. D, it consists of OCS3 which exhibit minus I plus R. These are the 4 possible variations. So let's say in case of group, I have taken this. What will be the rate of reaction? Highest, lowest to lowest. A greater than B greater than C greater than D, like this. All other center, post your answers. Arrange A, B, C according to the rate of reactions. Both the answers are not correct. Look at, in case of B, this is a NO2 group. NO2, it shows minus R effect. This is the structure of NO2, the minus R effect. This is the resonance of NO2, right? This NO2 group, if generate positive charge to this carbon, the electron will be shifted towards carbon and the bond will be more stronger. The bond will be more stronger. So B, highest B is not the correct answer. So what will be the correct answer for highest A, B, C, D? A, then C, then. Why D is least? Plus, then the plus R is dominating. As we know that the plus I effect, it pushes electron towards nitrogen, the bond cleavage will be much more faster. So why plus R, the rate is slow? Because if you take NO, OCS3 group at para position, it forms a double bond between carbon and nitrogen due to plus R effect. The bond which you want to break, if converted to double bond, the rate will be very slow. because the bond अब double हो गया ना, नहीं है? तो आप ये बोल सकते हो the group which exhibit plus I effect only, the group which exhibit plus I effect increases the rate, minus I effect decreases the rate, minus R decrease, whereas plus R stop the rate by forming partial double bond. Clear? So from diageneum compound, you can able to prepare almost all alkyl halide, including chlorobenzene, bromobenzene, iodobenzene, and fluorobenzene. You just have to add in this nucleophile in place of this nucleophile HCl, HF, HI, HBr at room temperature. Clear? If you want to increase the rate of reaction, just put one methyl or alkyl group which exhibit plus I effect. Which exhibit plus I effect. Apart from that, there are several other methods of preparation which you can able to, we have already completed in alkane topic. For example, if alkane CH4, if you react this alkane with halogen in presence of photon, you will get is this reaction is good to prepare alkyl halide? Or is there any drawback? What is the drawback? See, in the first step, this X, it gives 2X radical. Second, this X radical, methane to give HX and CH3 radical. In the third step, this CH3 radical combined with plus X radical. Now this X radical again react with this. So it is very difficult to control the rate of reaction. Clear? So in the first step, in the first step, I have prepared two radicals, right? But in the third step, this methyl group can combine with one X radical because one X radical is consumed, one is left. So this CH3 radical can able to combine with the X radical which is left in the first reaction. But I have reacted with this with X2. Why? If this CH3 radical combined with the radical present in the first reaction, then almost all drawback are fulfilled. No new free radical form. The major drawback of this reaction is the control. This reaction cannot be controlled because if you take one photon, it will react approximately billions of molecules through one photon. Second thing is that I have started the cleavage of XX. If I put the cleavage of CH4, photons can also break the bond between CH. H radical and CH3 radical may also form. Then different type of byproducts start forming. But this reaction is not taking place. Why? Because the photon which we have added are the quantized photon. For example, let's say if C and H bond cleavage energy is X joule, XX bond cleavage energy is Y joule. I have taken Y equal to Hc upon lambda, the value of lambda I have added in this reaction. So the quantized energy is for X2. Therefore, X2, the bond cleavage occur and the reaction is initiated. So there are three types of reaction initiation, reaction propagation, reaction termination, which I have already read in the alkane topic. But the major drawback of this reaction is it's difficult to control the reaction. If you want to prepare CH3X, you will get at the end of the reaction CX4. Still, if you want to prepare CH3X, what you will do, you will increase the concentration of methane, decrease the concentration of halogen, then you can able to control somehow CH3Cl. But at the end of the reaction, you will get a mixture of CH3X and methane. Again, it is a very difficult task to remove CH3X. The second drawback of this reaction is, let's say I have a molecule like this. and I have treated iodine. Let's say there is a chiral carbon. If the radical form, the chiral carbon, the radical form, it is sp2 hybridized, the iodine may attack above and below the plane and the complete racemization occur. So we cannot able to prepare one single product. So this is the second drawback. Third is reactivity selectivity principle. According to that, the highly reactive are fluorine, then chlorine, then bromine, then iodine. And iodine are the most selective one. So if a alkane consists of different type of group, let's say CS3, CH, CS3, CS3. This hydrogen is tertiary hydrogen because this radical carbon radical are tertiary. This hydrogen are primary. So the probability to attack with the primary are 9, whereas the probability to attack the tertiary is 1. If you take I radical, it will remove this hydrogen. If you will take F radical, it will remove this carbon. So reactivity principle and selectivity, which you have already completed in the alkane topic, all concepts are applicable in this method of preparation. Is it clear? कोई डाउट है? मैंने इसको पढ़ाया नहीं क्योंकि तुमने पहले से पढ़ा होगा. ठीक है? So let's start with the chemical properties of alkyl and aryl halide. Almost all major reactions are covered in method of chemical property of alkyl halide. So before start with the alkyl, let's start SN1 and SN2 reaction mechanism. Write down SN1 and SN2 and partial SN1, E1, E2, even CB, SNI. These are the reaction mechanisms which are take place in a single alkyl halide molecule. SN1, SN2, even E2, even CB, SNI, and substitution using neighbor group participation, NGP. Okay. So we can start these topics in the next class. Okay.
Okay. All right. My name is Dr. Shaman Kumar. I recently finished my PhD from University of Edinburgh, and before that, I did my master's in financial mathematics from the University of Edinburgh. I am here to teach continuity and differentiability. You have already seen limit and questions on that. Somebody else taught this topic. Today, I'm going to discuss the following topic. Can everyone hear me? Okay. So the first topic will be the definition of continuity of a function at a point, and then we will see, then we will translate this to the continuity on the interval. After that, we will discuss some types of discontinuities, for example, removable discontinuities and jump discontinuities. Then algebra of continuous functions. Then examples of continuous functions such as polynomial functions, rationals, exponential, and other things. After that, differentiability of a function at a point, and then we'll translate this to some interval. Then algebra of differential functions, as we see the algebra of continuous functions. So that then there are two rules: product rule and quotient rules, and then some problems that I have selected for this lecture. Okay, so I start with the continuity. So continuity. When we say continuity, that means there is no break, which means when you plot the function on a graph, there should not be any break in the graph of the function. Which equivalently, people usually say that if you start drawing a function, the function should the pen should not leave the page. This is the common terminology that most of the people usually apply to test whether a function is continuous or not. But this terminology is just a layman terminology. Technically, this is not right, because there are some functions which are continuous, but in order to draw this function, you have to pick up the pen while drawing the function. All right, and we will see some examples based on examples of this. But for the time being, let us say that the continuous function is a function which in order to draw the continuous function, the pen do not leave the paper. Okay. Examples could be let us say I have a continuous a constant function which takes a value c, which is a constant for all x in R. Okay. So let us say that we have the c here, and if I have to draw the function will move like this. Okay. So this is a continuous function. Similarly, if I write fx is equal to x coming from R. So in order to draw this function, this will go like this. So I don't pick up my pen while drawing this function. Okay. So this is a layman term. If we talk about some more technicalities of the continuous function, you have already seen the definition of a limit of a function at a limit at a point. And what was the definition? Do you remember? So this definition of the limit says that for every epsilon greater than 0, there exists a delta greater than 0 such that fx minus L is less than epsilon whenever x is less than delta. So this difference, which means that if I have a function something like this, and this is my point C, So I am so I'm drawing an interval here. The corresponding interval of the function will look like this. So let us say that this value is L. Okay. So what we see, if we move from this to this side, so if I move from the left to the point, then the function moves from this to, okay, so this is decreasing function, so from this to this. If I move from the right, then the function moves to this. So the left limit and the right limit both goes towards a number L. Okay. Now if I define my function in such a way that this limit is also the value of the function. Okay, so we replace this by the value of the function, which is C. So then we say that we have a continuous function. So if this condition is satisfied, we say that f is a continuous function. All right. So we see some. So in this way, so what we have seen here, the left hand limit and the right hand limit both should exist in order to define the continuous function. So I put one first condition that the left hand limit and the right hand limit, they are both of them exist. The second condition we have to impose is that left hand limit should be equal to the right hand limit. Okay, and so these two conditions leads to this comes from the definition of limit. If I add impose another condition that left hand limit is equal to right hand limit, and this limit is the value of the function at this point, then we say that the function is continuous at C. Okay. We are going to see some examples where these conditions are not satisfied. If you want to talk about some examples of the continuous function, so you can test that this function is continuous for all x in R. Similarly, you can say that this function is continuous for all x in R, because all these three conditions will be satisfied if you take any point. Now what happens if one of the conditions are violated? One of the conditions is violated. So let us we start from the last. So let's say that this condition is violated, the third one. An example for this could be if we define fx is equal to, so you are familiar with this notation, greatest integer function, you know this. And let us say that my x is between 0 and 2 pi. So this function will look like the following. So 0 pi by 2, pi, 3 pi by 2, and 2 pi. Here we have 1. So it will start from 0, go up to 1, then come down, and let us say this is minus 1. So this is the shape of the sine x function. Now it says that we have to take the greatest integer. So my plot is not very good, so I want to say that the maximum is achieved at pi by 2. So at pi by 2, this is 1. So when we take the greatest integer of sine, so this will give me a function like this. This will give me a function like this. All the values, so between 0 and pi by 2, the values are between 0 and 1. So everything will fall on the x-axis, except the point at pi by 2. So only this point will remain there. This will fall down. So there is a jump here, and then this goes up to pi. What happens in the second interval? In the second interval, this will remain. So this is my 1, this is minus 1. So in the second interval, so this is the plot of the graph. So I hope that you could see everything. So this is the graph of this function. Okay, and we can see that in order to plot this curve, we have to pick our pen from the paper to draw this point at pi by 2, which is 1. Okay, so this is not a continuous function. And we also observe that the left hand limit and the right hand limit both exist. They are equal, but the value is not equal to the value of the function at pi by 2 is not equal to the left hand limit and the right hand limit. Okay. Okay. All right. So this function is not continuous, but this kind of discontinuity can be removed. So this is known as removable discontinuity. Removable discontinuity. How do you remove this? You can define this function. You can remove the point from here. So I remove the point pi by 2 from this, and then I define this function as 0 when x is pi by 2. Okay. We can have an example where the second condition is violated. That is, we have the left hand limit and the right hand limit, but the limits are not same. And this is the classical example is the step function or the greatest integer function of. So if I take fx is equal to this, then the plot of this function will be. So it will start from here, and at 1 this moves to 1 and then remain there till, so this is 1, this is 2, and then jump again. Okay. All right. So I have we can see that left hand limit is equal to the right hand limit. Is not equal to the right hand limit, and so there is a jump in the function. This kind of discontinuity is known as jump discontinuity. Okay. We can also have some function where so I say condition 2 is violated. We can also have some kind of function where condition 1 is violated. We have already seen for 3. So we can also have a function where the left hand limit and the right hand limit, they do not exist. And we can define this function in this as follows. Can you see my letters, or should I write it in there? Is it fine now? X is not equal to 0. All right. So the plot will look like this. At 0, this is 0. And then the curve is the following. So when x goes to 0 from the right, it goes to infinity. When x goes to 0 from the left, it goes to minus infinity. Okay, so the limit does not exist. Okay. Now, so these kind of discontinuities, they're also irremovable. Irremovable discontinuity. Okay. Now, as I said, this technique to test the technique of drawing the function without removing the pen from the paper is not technically a good technique. So so there are examples for that, and let us say that I have a function fx is equal to x square minus 4 divided by x minus 2. Okay. So this is a continuous function. The equivalent function for this will be x plus 2. So that means if you plot this function, now 2 is not part of the domain of the function. Okay. So if you plot this function, so x, this is so when x is 0, the function will look like this. Okay. And let us say that this is 2. All right. And what I'm saying, I am removing the point 2 from the domain. So I remove this point. So the function is not defined on this point. Okay. But this function will be defined for all x belongs to R. All right. So this is another example. Another example could be fx is equal to 10x. And 10x, we know that this will look like this. So you can write pi, then 3 pi by 2, and this will look like this. So in order to plot this function, you require to remove the pen from the paper. Okay, but since the infinity is not part, these are not part of the domain, so this function is well defined. This is a well defined continuous function. Okay. All right. So there is another kind of function which we have. Let us say fx is equal to sine 1 over x when x is not equal to R, when x is not equal to 0, and 0 when x is equal to 0. So this function will fluctuate very heavily between, so when it goes towards 0, so it will fluctuate between 1 and minus 1. So there is a huge fluctuation. So if I take the limit to 0, the value of the function will not go anywhere. it will either be 1 or -1. So there is a huge fluctuation. So because of that, this is also not a continuous function. Okay, so this is oscillating discontinuity. Okay, any questions so far? All right, so then we can talk about the continuity over the interval. So when we talk about continuity over the interval, that means the function is continuous at each of the point in the interval.
So when we are taking, we have to write a new marker. This is not visible through our widgets. Actually,
Okay.
the vessel marker is not visible.
Okay.
And so that's the students in the class more interactive. I'm just saying because this video will use zero time. So that's why I'm just as a friend, I'm just
Okay.
giving you a suggestion.
So can they hear me, or can I
Yeah.
talk to them, or all the students? Okay. All right, so we have seen continuity of the function on a point. Now continuity of function on the interval. So I'll quickly go through this. So when I say that continuity of the function on the interval, that means the function will be continuous at each point of the interval. Okay, and the test will you will test whether the function is continuous over the entire interval by picking any arbitrary point. And if this works for any arbitrary point in the interval, then we say that this is continuous at each of the point. Okay. And do you understand the meaning of the arbitrary point? You pick any arbitrary point, let's say y, and then you don't fix the point. Okay. All right. So what is that? Okay. So in this is well known that fx is equal to tan x is continuous. The easy way to see is the following: sin x divided by cos x, and sin x is a continuous function. You can plot the graph of the sin x, so which will be a wave, sine wave, and also the cos function, which is the cos wave. And the ratio of two continuous function, that will be the part of the algebra of the continuous function. The ratio of the two continuous function will be a continuous function, provided the denominator exists. Okay, so the points which will make this infinity, you have to remove those points. And if x is equal to pi by 2, cos becomes 0, which brings this, which will bring this function to infinity. Okay, so all the points where this function is infinity will be removed. So pi by 2 to 3 pi by 2, and so on. Okay. Is that fine? All right, so so we move to algebra of the continuous function, and these results will be very useful to solve the problems. So this says that if f and g are two continuous functions, then the following holds. The sum is a continuous function. The difference is also a continuous function. Product is also a continuous function, and the quotient is also a continuous function, provided gx is not equal to 0. So can we change? So these are well. We are not going to discuss the proof of these results, but you can keep these results in mind that these holds, and we can have counter examples for these results, which says that if so the reverse does not hold. So if I have a continuous function, if I have the sum as continuous, it does not imply that the individual functions are also continuous. Okay, and you can test this with this. So if I define 1 when x is rational, and -1 when x is irrational. Similarly, let us say my g is -1 at rational and +1 at irrational. If you sum these two functions, so when x is rational, you get 1 minus 1, which is 0. When x is irrational, you get -1 plus 1, which is 0. So the sum will be a continuous function, which is 0 for all x on the real line. And is a constant. So constant is a continuous function. So the sum is continuous, but you can see that they are not individual elements. Individual functions are not continuous. Similarly, you can construct this example by taking f and g equal. So you can say that f is equal to this, and g is also equal to this. Okay, so that the difference will be 0. And then you get the difference as constant, a continuous function. How about this? So if I take these two, then the product will be, when x is rational, the product will be -1. When x is irrational, the product will be -1. So in the product will be -1, which is constant, but they are not continuous. How about this? So if I take the same function as we constructed here, f(x) is equal to gx, where g and f both are this. So you get fx is equal the fx divided by gx as 1 for all x. Okay, so this is also very clear now. And then we move to okay. So so we talk about this algebra, and then we move to. Can you display the topic, please? So now we talk about a little bit about the differentiability of a function, and then after that we discuss some questions. Okay, so let us say that I have this curve and I'm interested in finding the derivative of this function at c. Okay, so I have to, so let us say that I construct this secant and bring this secant from the right. So when you bring this secant from the right, you get the right hand derivative. Okay, similarly you can bring, so you have something like this, so you get this point, this line which is tangent to the curve at this point. Similarly you can move down all the secants and then you get the same thing. So if this happens, then we say that the function is differentiable at a point. Left hand derivative is equal to right hand derivative. And what is left hand derivative? Left hand derivative is we are coming from, or let us write in the reverse order. When s goes to 0, right hand derivative will be from the right hand side when x goes to, and if these two coincide, then we say that the function is the function is differentiable at x. Okay, f is differentiable at x if left hand derivative is equal to right hand derivative. So which means that when we move from the right, we get some line which is perpendicular to this curve, and similarly from the left I get some line, and if these two lines coincide, so I get a unique line, then we say that we have a function which is differentiable. Can you think of any function which is not differentiable? Mod x. So if I take fx is equal to mod x for x coming from R, so this function will look like this. Okay, this is 0. So all the secants will be will lie on this line when I'm coming from the right. So this will be the perpendicular from the right, and from the left this will be perpendicular, which are there, and they are not equal, which is clear from the picture. And so in some of the questions, if you know the plot of the graph, then it is very easy to identify whether the function is differentiable or not at certain point. Okay, so this technique is also very useful. As we have seen as we have seen the algebra of the continuous function, so similarly we can also have the algebra of the differential of the derivatives. So this is as follows. Algebra of derivatives. So f and g are differentiable then sum is differentiable and the derivative of the sum will be the sum of the derivative. So this dash denotes the derivative. You are familiar with this notation? And this will be equal to f dash x plus g dash x. Similarly, the difference is also differentiable. And this derivative is the difference of the derivative. What happens with product? This is also differentiable, but then the product is not equal to the product of the derivatives. So the derivative will be differentiate f multiplied with x multiplied with g so this is the change that we have to remember in terms of product. And this is also differentiable, but then the product rule and the quotient rule. You are familiar with this? Okay. Any questions so far? Okay, and I will give one more result for the derivative, and this is as follows. So this is already on board on the slides. So if you see the second point, so it says that f is differentiable, then modulus of f is differentiable for all values of x for which fx is not equal to 0. Okay, and we know that as an example, we know that if I take fx is equal to x, then this is a differentiable function. But modulus of fx will be this, and this is not a differentiable function. The derivative does not exist at x is equal to 0. Then it again says that, moreover, for the values of the function where this function is 0, okay, fc is equal to 0, modulus will be differentiable if and only if f dash c is equal to 0. In this example, at x is equal to 0, the function is not differentiable. What happens with the derivative at x is equal to 0? So at 0, this is 1. So this condition is violated. So this result can also be used to check whether the function is differentiable. So if I take, okay, so my question is, if I take fx is equal to x cube, let's say. So you get this, or you can write You can write this as mod of x3. Whether this will be a differentiable function or not? Why? So apply this test. And this also, so you can use these two things, that you have a composite function g of f. So f is differentiable at c and g is differentiable at fc. Then the composite function f g of f is also differentiable at c, and the derivative is given by this, which is chain rule. Okay, so if you apply this, then you see that this function modulus x was not differentiable at x is equal to 0. But when you take the derivative of this, you get 3x square, and this is 0 at x is equal to 0. So this if and only if conditions where the function is 0 and the derivative is also 0 at the point. In this case, the function was 0 at x, but the derivative was not 0. The derivative was 1. In this case, the function is 0 at x is equal to 0, and the derivative is also equal to 0. So using this rule, this function will be differentiable. Okay, and intuitively you can see that you are increasing the power, so that means you are making the function smoother and smoother. So how do you change the nature of this function? By increasing the power. That was my initial function, mod x. Okay, if I increase the power, so what I do, if my function, if my values are between 0 and 1, and I square these values, so this will be much lower. So this will fall below this straight line on both the sides. So this curve will look like this, and then goes above this straight line. And similarly, this way. Okay, so when you are bringing this function, when you are squaring this function modulus of x, you are making this function smoother at 0. Okay, and when you do the qth power, this is much more smoother, and raised to 4. So as you increase the power, this function becomes smoother and smoother, because this kind of thing is removed. Okay, so this is also a differentiable function. Where do we, so there are situations, if you see that there, so I will give some plots. So if your plot consists of this kind of, if the function consists, if the graph of the function consists of these kind of plots, then the function will not be differentiable. So non-differentiability, non-differential cases, we have already seen this thing. If I have this is not differentiable at 0. If I have something like this in my plot, then this is also not differentiable. You can take the mirror image also. Of this case, for this case, the mirror image will be this. So this is not differentiable at 0. Okay, and similarly, if you take the mirror image of this, you get this. So this will also be not differentiable. Now, if you take this kind of function, so this kind of curve, if you get, this is also not differentiable. And intuitively, you can see all these you can see that all these curves has no differentiability at 0 because using the definition. So you start with this we have already seen. So you start with the right hand side, okay, with a secant, and then you move to this side so that you get a perpendicular. So when you move to this side, you get this one, okay, x goes to infinity. In this quadrant, we know that the derivative is the slope of the line, slope of the perpendicular on the curve, and the slope is given by tan theta. In first quadrant, tan theta is positive. So when you move this to this side, you get a positive slope, which is so this is the infinity case. The left and the right hand limit goes to infinity. When you come from the left hand side, in the second quadrant, tan theta is negative, so it goes to minus infinity. The left hand limit goes to minus infinity. Left hand derivative will be minus infinity, right hand derivative will be plus infinity. Similarly, you can see the same thing here. So you can analyze these things. What will be the left hand derivative and the right hand derivative? And also here, so what will happen here? From this, you're coming to this side. So, so what happens here? So the tan theta, okay. So the tan theta will so in this case also, the tan theta is positive here and the positive here. Okay, so maybe I'm drawing the curve wrongly probably. So yes, yes. So that's why I'm saying that I'm drawing the graph wrongly. So you are coming from this side, so you get you go to infinity, and then you are coming from the left hand side. So I can write, so you are coming from the left hand side, and this is also again infinity, okay, because tan theta is positive in this quadrant. Similarly, you can draw the mirror image of this, and so what should I, so do you guess, can you guess what will be the so I'm coming from this side, so this goes to minus infinity, and then I want to come from this side, so this goes to again minus infinity, because in fourth quadrant and tan theta will be negative. Okay, so if you see these kind of patterns in your graph, so again I should remove this one. If you see this kind of pattern in your graph, then you can identify the whether the function is differentiable or not. Okay, any questions so far? Okay, so can you go to the topic? All right, so we have discussed chain rule, product rule, quotient rule. Then we can move to the questions now. So maybe you go down, scroll down a bit further. Okay, now problem number 1. Examine the continuity of this function. Do you have any idea? Examine the continuity of the function. No one? Okay, and then okay, that is one of the way to prove that this function is continuous. I have given you some algebra of the continuous function. So yes, can you apply this algebra now? So this is continuous because I know that modulus of x is continuous, 1 minus x is continuous, sum of two continuous function will be continuous, and then again modulus of a continuous function will be continuous. Okay, so this is a continuous function for x belongs to R over the entire interval. So using these elementary properties, we can quickly check that this function is continuous. Now go to exercise 2. So we are given this function, and we have to find the values for p and q for which this function is continuous for all x in R. Okay, how do you do this problem? Anyone? Okay, so maybe I'll solve this question for you. So we, from the definition, we say that left hand limit is equal to right hand limit is equal to value of the function at 0. Okay, so that means what is left hand limit? S goes to 0 from below, and this is my left hand limit. This is right hand limit, and since I'm taking this x as 0, so I will replace all the x by 0. Okay, so this will give me two equations. The left hand limit is equal to the value of the function, the right hand limit is equal to the value of the function, and I have to determine two unknowns, p and q. So what happens here when x is coming below 0 from this part, when x is less than 0, the function is this. Okay, so this left hand limit will be sine p plus 1 and so if you want to write more explicitly, left hand limit will be, or maybe I write it here. So this will be sine p plus 1 and x is 0 minus h plus sine 0 minus h divided by 0 minus h, and from the right hand side I get 0 plus h. This was the right hand side, x greater than 0, so I get 0 plus h and plus 0 plus h square divided by 3 by 2. And what happens here when x is equal to 0? This is q. So this means and I'm forgetting the limit as goes to 0, limit as goes to 0. So limit as goes to 0, sine p plus 1 h, and I get minus here. So I remove this minus and write sine h. So you get minus here, you get minus here, but this cancels this minus. Okay, so I get this, and this will be three by two, which is equal to q. So limit at h goes to 0. I can apply the algebra of limit. Sum of the limit is, so I can separate this. And here I can see that I can cancel some of the terms. So I can take square root of h common out and then cancel this with this. So I get h goes to 0. What do you get? 1 plus square root minus 1 h, which is equal to q. And then, so are you familiar with this formula? Is equal to 1. Okay. So you apply this. So what do you do? So maybe I write it here. So p plus 1, and then you can divide and multiply by p plus 1. So you get 1 and 1 here. So that is p plus 1, and what do you get this? This will be 1. So when h goes to 0, you get 1, minus 1 is 0, and you get 0. So 0 by 0 form. So in 0 by 0 form, what do you do? L'Hopital rule. Okay, it's not L'Hospital rule, it's L'Hopital rule. I also used to say L'Hospital rule when I was in your age, but later on somebody told me it's L'Hopital rule. And I guess this is a French name, probably. French has a very different pronunciation. So, okay, so we go back to the lecture. So when you apply this, you get this divided by 1. This is equal to q. H is equal to 0. This becomes 1, so you get 1/2. Okay. So this equation gives me q is equal to 1/2, and p will be p plus 2 is equal to q, or you can say this will be minus 3 by 2. Okay, so what is the answer? So B is my answer, minus 3 by 2, and q is equal to 1/2. Okay, can we go to the next question? Yes. Okay, so this is a very interesting question. Anybody has any idea about this question? Examine the continuity of this function. By the way, you understand the rational and the irrationals. When I say rationals and the irrationals, okay, so this is not very difficult. I have given you a function in the beginning when x is rational, and minus 1 when x is irrational. Can you tell me whether this is a continuous function or a discontinuous function? This is a continuous function or a discontinuous function? Discontinuous, highly discontinuous, because it jumps at rationals and irrationals, very frequent jumps. And rationals are countable, but they are very dense in real line. So because of this denseness, around every rational you will be able to find an irrational number where this function will move to -1. Okay. But what happens if I change the nature of the function? So instead of a rational, if I take x, can we talk about the continuity at a certain point? So what kind of function is this? When I have irrational, I will put, I go down to -1. When I have rational, I determine the element using the straight line value of the, because fx is equal to a straight line. This continuous at every x, or there are some points where this is continuous? Say again. So, so this function will be continuous when x is equal to -1. Okay, so you equate these two and find the value of x which satisfy this equation. Okay, and this is a very, very general reason. Why is this so? So let us have, you have -1. You start approaching towards -1 on the real line. So there will be rationals and irrationals. And it says that whether you have a rational or irrational, both will go to -1. Okay, the function will go to -1. There is no fluctuation here at -1, whether you are coming from rationals or coming from irrationals. Okay, so now go back to this question number 4. So what do you say? What can you infer about the continuity of this function? X is equal to 3. So I will equate these two parts. 2x is equal to x plus 3. This gives me x is equal to 3. So at x is equal to 3, this function is continuous. If I change this to a little bit like this, let's say I have x square and 1, then what happens? -1 and 1. Because you solve this equation, x square is equal to 1, and this gives me plus minus 1. So this will be continuous at plus minus 1. Similarly, if I say I have x square here and let us say minus 2x, or maybe right, plus 2x minus 1, then this will be x square is equal to minus 2x plus 1, and this gives me, oh, this is minus 2x minus 1. So this will give me this, and I get a perfect square, and I get x is equal to 1. So again, this function is continuous at x is equal to 1. Okay. Any questions so far? All right. So we move to the next question number 5. So we are given this function now, and we have to identify which statement will be true and which one will be false. So what do you think? A is true. Start with A. Fx is continuous at x is equal to minus pi by 2. Is it true? For continuity, we check left hand limit, right hand limit, and the value of the function. The value of the function at pi by 2 is 0. When we move from the left of pi by 2, we get 0. When we move from the right of pi by 2, we get 0 because cos pi by 2 is 0. So the first statement is true. Fx is continuous at x is equal to minus pi by 2. How about the second statement? Differentiable. Okay, so the B is fx is not differentiable at x is equal to 0. So construct the left hand limit and the right left hand derivative and the right hand derivative. What happens there? So when x is left hand derivative will be limit s goes to 0. 0 is the point where I'm interested in finding the differentiability of the function. Divided by h. So f0 is cos 0, which is minus 1, and then I have cos okay, divided by h. So this will be you can apply the sign, so you get what do you get? Minus 1, and right hand derivative will be so from the right hand side of 0, this is x plus x minus 1. So h minus 1, and at 0 this is so when x is equal to 0, what do I get? Minus 1. So this is plus 1, and I get 1. Okay. So the left and the right hand derivative, they are not same. So this is not differentiable at 0, which is a true statement. How about the third part? Fx is differentiable at x is equal to 1. So again, you apply the same thing, and so when you see, you can see. So what is your guess? What is your guess? Do some little bit of calculation. Find the left hand derivative, and left hand derivative at 1 will be 1 minus h minus 1 divided by minus h. So you get 1. Right hand derivative will be f x plus h. So 0 plus h will be ln h. Just a second, I'm doing some mistake here. So this is this is 0. Okay, so you can do this calculation and check whether this is differentiable or not. And I think this will come out to be differentiable at x is equal to 0. So do this little bit of algebra and similarly apply the same technique, the left and the right hand derivative for the last part. And I think this is true for all the statements here in the question will be true. Okay. Now let us move to the next question. Okay, so f is defined by maximum of x and x cube. You have to identify the set of the points where fx is not differentiable. Any idea? Do you think is it easy to plot this curve? So you have 1, you have -1 here. What is maximum between 0 and 1? X will be maximum between 0 and 1. So you have this, and then x cube will be maximum after 1. So it goes like this. What happens here? X cube will be maximum, and then it goes like this, straight line. Okay. So the points will be, so you can see that when you come from the right, you get this perpendicular. When you come from the left, you get this. So that means you get different lines, not the unique line. Yes, so it's not differentiable over this set. But simply using the definition, because you start with the right hand side in this part and then move down, you do not get exactly the same straight line. You get something like this. Okay. This will be perpendicular here, and this will be the perpendicular here. You see? And similarly, this will be the perpendicular for this curve, but for this curve, for the straight line, this will be the perpendicular. So you don't get a unique perpendicular on these points, -1, 0, and 1. So this is also not, this function is not differentiable at -1, 0, and 1. Okay, so my advice is that if you are able to draw the function, graph of the function easily, then draw the function and check whether this is differentiable or continuous. So in order to test the continuity or the differentiability, if the graph is available, then everything is fine. If the graph is not available, then you have to use the definition, okay, and the test. Also think of the algebra of the functions, algebra of continuity, and algebra of differentiability. If this also gives you some answer or some clue, then that is also fine. But you have to keep in mind that the reverse does not follow in each of the case. So you cannot go back. If you have if you are identifying the sum as a continuous function, you cannot go back to the continuity of f and z. Okay. Now let us move to the next one. Okay. So question number 7. What do you think of this one? Do you have a question number 4? Okay, so there is a question where I have to explain question number 4 again. So maybe I draw this function again. So I take fx is equal to 1 when x is rational and minus 1 when x is irrational. So what do you think of this curve? I have real line minus infinity to infinity, 0 is here, and there are countable number of rational numbers on real line, but they are dense. You can count the rational numbers, but they are very dense. So if I have a rational, let us say I have a rational here, then then the function takes value. Let us say I have a rational here, the function will take value 1. So this is the value. But if I have immediately after this rational, you will be able to find an irrational number. So immediately after this, you have irrational number. So this goes to minus 1. Okay. So what do you see? In order to plot this function, you have to lift your pen. So the continuity is not there. But if I change a little bit, if I change this to x, then the continuity will be achieved at x is equal to minus 1. Because at, so let us say I have minus 1 here. Okay. So when I approach from the left, I will have rational and irrationals, and both the case will give me minus 1. Similarly, if I approach from the right, then also we have rational and irrationals, and both the case will give me minus 1. Okay. So this will be a continuous function. So the left hand limit will be equal to the right hand limit, and this limit will be same as minus 1. Minus 1 is a rational number, and at rational number this is x. So x is equal to minus 1. So left hand limit is equal to right hand limit is equal to the value of the function at minus 1. Okay. Now for this case, in question number 4, if I have 2x and x plus 3, so whenever I have a rational number on the real line, I am taking the value of the function using 2x. I put a rational here, and whatever value I get, that will be the value. Okay. And if I have irrational number, then I will take the value from this x plus 3. So I'll pick an irrational and substitute it here. Okay. Now I have to test whether this is continuous at any point. So what do you think? The point where, so let us say I want to identify a point where I get the left hand limit equal to the right hand limit. So if I move from the left to this point, so I will have rational and irrationals both. This point should be chosen in such a way that I get the same value in both the case. Okay, so what will be the same value if I equate these two? So if I solve this equation, x plus 3, I get x is equal to 3. So that means my C is 3. So I am approaching towards C from the right. So I will have rational and irrationals. Value of the function will be, if I have rational, then the value will be 6. If I have irrational, the value will be 6. So whether I have rationals or irrationals, the value will approach to 6 if I am approaching from the right. Similarly, if I am approaching from the left, I will have rational and irrationals on the left of 3, and both will lead to 6. So the left hand limit is equal to the right hand limit, that we know. What happens at 3? 3 is a rational number, so I get 6. So the value of the function is also 6. Okay, is that clear now? All right, so let us move to the next one. Question number 7, I guess. Yes, so question number 7 now. So we have a function from R to R. This function satisfies this additive condition, fx plus y is equal to fx plus fy for all x and y in R. F is differentiable at x is equal to 0. Then which of the following are true? A, B, C, and D. So what do you think? How should I approach this problem? No idea? Okay, so are there any other question or? So we are given f x plus y is equal to fx plus fy. Now if I take x is equal to y is equal to 0, what do I get? F0 here, and on the right f0 plus f0. This means f0 is equal to 0. Okay. Now let us find the derivative of this function. So left hand derivative will be s goes to 0 f 0 minus f 0 minus h divided by h. So the limit will be, I know f0 is 0, so you can write this as 0. And what happens here? I can apply this formula. This is given to me. So this will be f0 minus f of minus h divided by this. And then I get this one. We are also given that f is differentiable at 0. What happens right hand derivative? So apply this one. We are given that left hand derivative and right hand derivative, they are same. Because this is differentiable at 0. So what do you get? So when x goes to 0, and so maybe I write it this as follows. Since this is differentiable at 0, so using this property that the function is differentiable at 0, this thing is same as this. You can also see from here. So if I don't include this 0, so if you forget about this 0, so what do you get? F0, f minus h And so if you apply the derivative of the function at 0, you get the same thing without this 0. So that is the derivative, the left hand derivative at 0 and the right hand derivative at 0. So the derivative at 0 is a constant. So f is continuous because we are already given that this is differentiable. So f is continuous. So this statement will be true, and this derivative will be a constant. Okay, so the C is also true.
So if it's Udaan's differentiable at x equal to 0, or we have like anything on this greater than x equal to that line.
This will since this will come out to be a constant function. Okay, so since the derivative is constant, so I'm confused probably. Okay, maybe I explain this later on and move on to the next one. I'll come back to this one. So we move to the next one. Now question number 8. So we are given that f is a differentiable function satisfying this condition. Then prove that f is a constant. The function f is constant. So how do you do this? So we are given this condition. So if I take y is equal to x plus h, then I get x plus h. So I get minus h raised to q. Then we can divide this by h. So I get h square, and then take the limit. Okay. So I get the derivative of the function at x is equal to at x, and the right hand limit will be 0. So this means, and this is a positive quantity, so this implies that f dash x is equal to 0. Okay. So if the derivative is 0, that means the function is constant. So this implies f is constant. Okay, now move to question number 9. Now similarly, you can apply the same thing here. So we are given that f is a differentiable function satisfying this condition for all x and y in R, and we are given that the value of the function at 0 is 0. Then you have to find the value at 1. So this is similar to this question, but this is explained. This is written in different form. Instead of saying that f is a constant function, you have to find the value of the function at 1. So you can do the same thing. So this will be square, and you get square here. this is h, and then you get the derivative at this. So that means my function will be a constant, let us say c, and we are given that when x is equal to 0, f0 is 0, but when x is 0, this function is c, that means c is equal to 0. So fx is equal to 0. So what will be? This will be 1. This will be 0. Okay, so D is my solution. Now the next one. Now question number 10. This is again the same thing, but again written in different form. So it says that identify the equation of the tangent to f at this point. So what do you think that will be the solution? So again you will write y is equal to x plus h, then divide this by h, check the limit, then you get 0, the derivative is 0. The derivative of the function is 0, that means the function is constant. And the function is constant means that we are given that at x is equal to 1, the value of the function is 2. So the constant will be 2, which means the function is y is equal to 2. So what is the tangent to this function? Y is equal to 2. Tangent to a straight line is the line itself. Okay, so y is equal to 2 is the tangent. Now the next one. Yes. So what happens here? We are given that fx is equal to this when x is between 0 and pi by 2, and f is continuous between 0 and pi by 2, and we have to find the value of the function at pi by 4. So how do you tackle this question? Continuity will imply the left hand limit and the right hand limit, they are same, and they are equal to the value of the function. So the only thing that you have to find is, in order to find this, you have to find the left hand limit or the right hand limit. Okay, so how do you do this? The left hand limit let us say I do this from positive, so maybe I write h goes to 0. My value is pi by 4 plus 0. So I'm writing left hand limit and then I'm writing right hand limit. So this is right hand limit. So 1 minus 10 pi by 4 plus h 4 minus pi. When x is not equal to pi, in both the case I'll get the same thing. So this will be this pi and pi cancels out. So what I have 4h. Okay. Now this is 0. So when s goes to 0, this is 10 pi by 4, which is 1. 1 minus 1 is 0, so 0 by 0 form. Okay, so this is 0 by 0 form. So we apply this L'Hopital rule. Over 4. And then what do you get? So what is the final answer? Give me the final answer. One by 2. Okay, so 1 minus is missing. So minus half. All right, so let us move to the next one. Now this is also a good one. So this is a bit interesting here. We are given fx is equal to this. F is differentiable at x is equal to 0. Then find the value of a. What do you think about the derivative of the function at x is equal to 0? We are given the right hand side, but not the left hand side. Okay, we are given that x is between 0 and 1/2, but nothing is mentioned about what happens on the left of 0. Okay, so if you apply this derivative, that f is differentiable at this, in order to find the value of a, the left hand derivative and the right hand derivative, they are same. You will since you do not have the left hand derivative, so you will not be able to solve this question. So what do you think we should do in that case? Yes, because the function is differentiable, so this function will be continuous at x is equal to 0. So you will, yes, so apply the concept of continuity. So the left hand, the right hand limit is equal to the value of the function. So what will be the let us write the right hand limit. So h goes to 0. So from the right hand side, this will be e raised to h, yes. Okay, and this will be equal to 1 by 2. No, I mean the value of the function. So this limit is when h is 0, this is 1 minus 1, 0 by 0 form. So apply L'Hopital rule. So you get h by a by 2 e raised to ah by 2, and then you get a by 2, and right hand limit is equal to the value of the function, which is 1 by 2. So a by 2 is equal to 1 by 2. This implies a is equal to 1. Okay, is it correct? All the calculations are correct. Now next one. Okay, so the left hand derivative of, find the left hand derivative of this function fx is equal to the, so this is greatest integer x multiplied by sine pi x at x is equal to k, where k is an integer. So I think this should not be difficult for you. The left hand limit, or should I explain it here? We are given fx is equal to and I have to find the left hand limit, left hand derivative, left hand derivative at k. Okay. So this will be okay, and then do this expansion. You can write this as, so I'm just giving the hint instead of solving the entire problem. So I can write this as pi k minus pi h, and then you apply the formula for sine a minus b. Okay, and when you do this expansion, you will see that only some of the terms will be cancelled out, and then at some place you have to apply this formula, x goes to 0, which is equal to 1. Okay, and this will give you the solution. And the answer to this question is, I think, can you reduce this a bit? I mean, zoom in. No, I mean, yes. Bit further. So A is the solution for this. All right. Okay, so I have a couple of minutes, I guess. 1 minute. So maybe I finish quickly. I have 2 more questions to discuss. So we go to question number 14. Okay, so in question number 14, you have to test the differentiability of this function. And as I said, you have to check the value. You have to, so this function will be differentiable except the value where, except for the values of x where this is 0. So the inner one, will give me mod of ex minus 1 is equal to 0. So find the value of x by solving this equation. And this one, and also this. So this will give me x is equal to 0, and I think this will give me log to the base 2, log e to the base, log 2 to the base e. So if you solve these 2 equations, then you will get these 2 values, and this function will be differentiable except at the value where this is 0. Okay, how about the next one? Now this is I think this function is easy to plot. So you have to find. Okay, so first of all, read out this question. So it says that fx is equal to whatever is the expression. You can see the expression on the slide. Has 3 point of differentiability. This is given. So for what values of a, this condition will satisfy. that this function has 3 points of non-differentiability. Okay, so since this function is consists of modulus, so I can plot this function on graph. So what is mod x? Absolute value of x is this. This is my mod x. Now I have to shift this by -2. So where this will go? Down. This will look like this. Then I am taking the mod again. So this is mod of x -2, and then I'm taking the mod again. So that means all the negative will become positive. So this will go up. So when I do this, so this part go up. Okay, and then I have this function. Now I have to add some constant. Let us say that a is a positive constant. So when you add a positive constant, this will move up in this way. Okay, so we will still have 3 points of differentiability, non-differentiability. These are the points. This is whatever is that, you can calculate this point. So this point, 0, and this point, these are 3 points of non-differentiability of the function. So I'm not bothered about calculating the points, because I just have to say for what value of a this will maintain, this will be maintained. So if I take a positive a means 2 and 1, part A and part C. Both these cases will give me 3 points of non-differentiability. But if I take negative a, this will go down. And then I'm taking, so do you see this? So if I take negative a, so this curve will go down, this entire curve will go down. So that means my curve will be something like this. So I bring this curve down and then take the modulus again. So that means if a is negative, so this is the case when a is positive. If a is negative, I bring this curve down and then take the modulus. So when I take this modulus, this part will go up. So what happens in that case? I increase the number of non-differentiable, number of points where the function is non-differentiable. So for negative a, this will not keep this condition, that 3 points of non-differentiability. So my answers will be A and C. Okay. Okay, so we finish now. Any questions so far? And if you have any other question to ask, you can give me the question and I can send you the solution. All right. And I do not know how this is managed. Do you send the question? Yes. So I can take the list of the question and then should I send the solution to who do I send the solution? Okay, so you can use all right. So maybe I give you my email ID. So write down my email ID. If you have any question, you can write me the email with your question and then I'll give you the solution. All right. Okay.